Good day to everyone. My name is Esa Halmetoja and I come from Finland. I am working as a senior expert in Senaatti Properties company. Nowadays, my responsibility is the digitalization of property maintenance and operations. My work includes promoting the use of IoT solutions in our buildings and introducing BIM in facility management, among others. On the next couple of words of my employer, Senaatti Properties is the Finnish state property care company. Our main task is to operate as a work environment partner for the Finnish government. Here you can see some of our key figures. We have about 8,900 buildings and 6 million square meters to lease. Our biggest customer is nowadays Finnish Army. They are using almost every other of our buildings, 49%. The offices are the next big, then various buildings including state schools, laboratories, etc. We also have many prisons and police buildings. Here you can see the amount of government personnel today. Total of 75,000 people are working for the Finnish state. 55,000 of them are working in Senate facilities on a daily basis. 14,000 of them are working in multi-space offices. And Senaatti Properties have about 350 experts. As you know, today almost everyone is working remotely because of the corona crisis. The state made a survey that revealed that every third of state employees does not want to return to the office after the crisis. And we have evaluated that after 10 years, the Finnish state needs 500,000 square meters less of spaces than today because of increasing of remote work. It is a great chance and we will see if it really happens. Now we are approaching the main theme of my presentation. Next, I will tell you about Senaatti Properties' vision on the digitalization of facility management and maintenance. Today, the amount of digital data is increasing enormously. A memory capacity of computers become cheaper and cheaper. The computing power is growing at the same time. Artificial intelligence is approaching everyday use. And finally, digital services are becoming cheaper, more effective, and more accurate. It can be seen that our challenge is to strive to utilize data wisely. Currently, Senaatti's organizational digi strategy is under developing. It will be published with a new total strategy in 2029. And the maintenance digi strategy will be a part of that ensemble. So I will not show the old one because it will be renewed on the next year. I see that the digitalization of facility management, it's crucial focusing on technologies to automatizing working environments, Internet of Things, wireless sensor networks, building automation systems, etc. It's also important focusing on BIM models to create future user interfaces, some kind of digital twins. And it's important focusing on big data to developing data-driven services. In this context, people are often talking about API economy and also about knowledge-based management. Here you can see how we see the benefits of using digital data in facility management. We see that sharing information increases transparency and trust and reduces worry, especially when we are talking about indoor air problems. Occupant reserves high-level services and excellent indoor conditions. The building owner obtains high-quality maintenance, low fault frequency, and high user satisfaction. And the property service provider reserves high profits, high using rate of resources, and increased customer satisfaction. Today we can say that the amount and availability of digital information is not a problem, but it's crucial what you do with this digital data. It is not important how much you have data, but are you able to utilize it intelligently? Next, I will tell you about 3 pilot cases where we have utilized intelligent data analysis. In the first analysis, we examined the relationship between user satisfaction, temperature, indoor temperature stability, and indoor air quality. The result is that a small positive correlation between satisfaction and temperature stability was found. Also, a moderate correlation between the freshness and odorless of the indoor air was found. And we found that when we are talking about indoor air, if one indicator is bad, others also are bad. And we found that this analysis was profitable. Even the result was not a big surprise. In the second case, we examined the relationship between user satisfaction on indoor air and technical quality of maintenance. And there was a positive correlation between technical quality and user indoor air satisfaction. That means that high quality maintenance provides high indoor air quality. So it's worth following and evaluating the quality of technical maintenance because it's an important factor in indoor air quality. And we consider this analysis very profitable. The third case was the maintenance data analysis using artificial intelligence. We used AI solution to collect data from project database and online document repositories. The aim was to find out whether the maintenance data is suitable for AI analysis. The used indicators were depth of repair, technical risks, impact of energy corrections, etc. And we found that our data was inhomogeneous with many shortcomings, for example, start or end of projects, project content, final cost, etc. And it was difficult to find relevant data from online repositories. Existing interfaces did not support the machine reading properly, and that was a big technical problem. And we did not find immediate benefits on this case. And the conclusion was that this analysis was not profitable for us. Here you can see the summary of our 3 cases of data analysis. We found that targets must be defined accurately. The needs must be defined by the customer, in practice the building owner, not by the vendor of an analysis tool. The source data must be selected carefully. Conclusions can be mostly as good as the source data is. And finally, the artificial intelligence is not wiser as the people who is using it. This means that artificial intelligence is faster and can handle enormous amount of data, but human must make conclusions anyway and any time. Next, I will present you how we see the building's digital twin in Senaatti properties. In this context, I will tell you about conditions data model, which is our version of digital twin. We see that the digital twin concept is a crucial part of digitalization of facility management, and that's the reason why I have included the CDM in this presentation. This slide presents how we see beams today. On the left, you can see the traditional as-built beam that is created by designers and contractors. This beam works as a base of the next renovation project and visualizations. The middle one is operations and maintenance model, OMM. That is a combined model which is intended for the property service providers. They can use it to seeking devices to maintain, recognize reasons for indoor condition phenomenon, etc. And finally, the right one is the primary topic of the last part of my presentation. It's the conditions data model, CDM, and you can also call it as a digital twin if you like. In this context, I ask you that please note that the two last, OMN and CDM, they are not new types of building information models. They are not new beams, but rather the new use cases for beams. This slide shows the content of operations and maintenance model. The OMM is a combined model presenting structures and equipment that require maintenance. It's intended as a tool for maintenance and troubleshooting, and it helps to locate facilities and equipment in there. It provides views of hidden maintenance and repair devices, and it presents the operation areas of building service systems. The slide on the figure on the right side of the slide is presenting ventilation machines operating areas. And this is what I want to see from all projects in Senaatti properties. The figure is origin of Tero Järvinen from Granum company. Very many of you know this company well. Conditions data model. As I said, it's not a new type of BIM. It is a digital service platform based on the combination of BIM and field data. Space user sees the situation of indoor conditions, gives online feedback, and sends service requests. Property service operator gets real-time information of indoor conditions and receives user feedback. And the building owner monitors indoor conditions and controls and manages user feedback and service providers operating. This slide presents the occupant's user interface of the CDM. It works on smartphone with the camera and the web browser. When the user reads the QR code that is installed in the room by a smartphone, he or she will reserve the web page to the device. The web page shows the conditions of the room. The temperature is always on and other quantities if they are measured, for example, carbon dioxide contamination. A user can give feedback using smileys, send a service request, or answer a survey. Here you can see a field crew user interface of the CDM. The temperature and other quantities are indicated by numbers and colors on the 3D planning. The smileys sent by occupants are also shown. The field crew can see when and from where the smileys have been sent. They don't know who sent feedback because the system does not recognize user or smartphone, but just rooms using QR codes. The field crew is also able to use BIM model for seeking faulty device or finding reasons for inner climate problems. On this slide, you can see the conceptual architecture of the CDM. On the right side are the data sources. First, IT solutions, QR code service, CMMS, CAFM. Those are some kind of service manual of a building, energy management system, and so on. The next one is building service systems, HVAC, building automation and sensors. And the last one is a BIM server, where we have recorded our BIM models, complying with IFC standards. On the left side, you can see the data users. The first one is an occupant who can use the platform by smartphone. The second one is property service company who can use the information using a tablet. And then the last one is workplace services who is coming. They are not today utilizing CDM, but they are coming soon. And on the top of all is the owner operator who is monitoring everything in the building and making wise decisions with the smart data. In the middle of this network is a data lake called Platform of Trust. It is a commercial platform that anyone can use. Its task is seek and combine data from data silos to stakeholders. Let us look at a simple example. For when the property service provider wants to see the temperature of certain room, they send a query to the Platform of Trust. Platform of Trust checks that the company has a permission to the information. Then it seeks the room from IFC model, and after it has been found, it seeks the temperature from building automation system. Then it combines them together and sends back to property service company for analyzing and visualizing. The task of Platform of Trust is seeking and combine information. This slide shows you the targets of the CDM. Our goals are not less than 1% higher performance of office work, at least 4% savings in maintenance costs, including energy costs, 10% higher user satisfaction. And we have estimated that the CDM's economic significance is approximately 4 million euros per year when 50 buildings and 15,000 users are involved in the CDM solution. It's obvious that achieving the savings requires that the processes of property services are renewed and the occupants are using the system actively. Of course, the implementation of the CDM IT architecture requires efforts at the beginning, but however, it's not very expensive when we are comparing it with other IT systems. In total, we have calculated that the entire system's payback period will be less than 5 years. This slide shows how we are proceeding at the present. The CDM covers 8 buildings today with 1,000 QR codes. About 2,000 occupants are involved. 4 property service companies are using mobile UIs. And 10 buildings more will be involved before the end of this year. And our target is that total of 50 buildings and 50,000 occupants are engaged before the end of 2022. We will see if we can reach this target. The new characteristics for CDM are understanding user service requests, cleaning, catering, back office services, energy consumption, and so on. Here you can see the observations of digitalization of facility management. Digital business models are emerging, whether you like it or not. The management by knowledge supersedes the management by applications. Dynamic information management and intelligent data processing supersedes silos. Service demand moves from data management to the knowledge management. And finally, digital twin concept will be a crucial part of digitalizing facility management and maintenance. Okay, thank you for your attention. I hope you enjoyed my presentation. Have a good day.
So we have some questions to you, Esa. Does Senaatti use digital twins in practice, or is it just a concept? So is it in the concept phase yet?
Yes, we are using it in practice in 8 buildings, and 10 more is coming before end of this year. And of course, it's a piloting phase, but we know that it's working, and we are waiting for reaping benefits after a couple of years. But yes, we are using it.
So, and one a little bit more practical question, what kind of software solutions do you use for CDM?
I can say that we are using all solutions. This is not a problem, who is the vendor or what's the name of solution, but the key is, or maybe I have to say the crucial is that we can use the data. And there is an API where we can fetch data to our system. And we are using everything, all architectural softwares for BIMs, and okay, there is some softwares for using IFCs. We have using BIM server freeware, but the data sources can be anything, anyone. Data is the crucial.
So as our next question is a little bit towards the future. So what are, in your opinion, the next steps and also challenges in building portfolio digitalization?
Well, I think that the next steps are the change in providing property services and servicing buildings. And I think that the platform economy and API economy are emerging on facility management. This is the next big step. And there are some problems with harmonization of data, as I said in this presentation, and also the cybersecurity can be a problem. But when we are handling data carefully, we can avoid those cybersecurity problems.
So, but what happens with the buildings in Finland if the internet is gone, if they are offline? So does your system collapses, or you can somehow restore it after the internet comes back? So how do you deal with this kind of challenge?
Well, the idea is that buildings are so smart that they can operate also without internet connection. And when internet connection is coming back, they are managing the situation what is online in the building, and there's no problems.
Okay, this is good to hear, that if buildings are offline, they are still smart.
Yes, they are smart.
So how well Finnish construction sector comply with Senaatti requirements? Is there enough skill, any confirmation?
Yes, very well, I think. There are some big companies, maybe it's not relevant to say names, but there are a couple of or 3 big companies in Finland who are already using quite similar solutions than our CDM is. And concerning the BIM modeling, the big companies are very good with that. But I'm concerning on little companies because they are not able to use or create BIM models. Big companies are okay in Finland.
But the next question would be that do you have any onboarding plan for the companies? How to help them to comply with your requirements? How to help them to be a better partner for you?
If you mean property service companies, the answer is yes, because we had competition recently, and we have now 5 companies in Finland who are using our CDM system, and we are supporting them a little bit by money, but more to developing the property service processes with them.
Okay, so one of my there is no other questions in the internet, but I have one in my notebook, is that how do you change the way how people think about buildings in Finland? So how do you make people think in the way of digitalization concerning buildings?
Well, I think it's not so that we have to change the thinking of people, but people are changing thinking of us and other building owners, that they are demanding better indoor conditions and smarter buildings and so on, and we have to respond to their demands.
Okay. So thank you, Esa. It was nice to meet you over the internet. And let's hope that after this corona crisis, everybody can meet with you in person and you can come to Estonia or we can go to Finland and share the knowledge. So thank you once again. Kiitos paljon.
Thank you. Yeah. Thank you. I will be there on the next year.
Yeah. So bye-bye.
Have a nice day. Bye-bye.